Alright, so today we're going to be talking about complex numbers. This is the next section in our chapter 4 lessons. It's also the last lesson before our quiz next Wednesday. So up until now, we've talked about some different types of numbers. But they have all been in the real number set. So remember that our real numbers are consisted of two different types. We have our rationals and we have our irrationals. So remember that our irrationals consist of things like pi, square root of 2, anything that's going to have a decimal that goes on forever. And all of these are inside of our real number set. Now, inside of our rationals, remember our rationals are anything that we can write as a fraction or that we can convert to a fraction. So like 1/2 or 0.25. Then within our rationals, we also have a couple of other sets. Remember that we have our integers, which are going to be our numbers like -2, -1, 0, 1, 2, and so forth. And then within our integers, we have our natural numbers, which remember our natural numbers are just like our counting numbers. So 1, 2, 3, etc. Now, the important thing to point out, though, is that all of these are still within our real number set. Now, outside of our real number set, we actually have another kind of number, which is going to be our complex numbers. And so notice that I have a set that is here, that's my real numbers, and outside of that is where my complex numbers are going to live. So let's look into those. Now, the first thing that we need to talk about is what's called our imaginary unit of I. Now, when it says imaginary, that doesn't mean that it doesn't actually exist. So it's kind of a bad name because it makes you think that it doesn't exist, but that's not true. It's just kind of in counterpart to our real numbers. So instead of like thinking about the opposite of real is kind of imaginary, that doesn't mean it doesn't exist. It just means that it's the opposite of our real numbers. Now, the basis for our imaginary unit of I is that I equals the square root of -1. Up until this point, you've been told that I can't take the square root of a negative. And that's true if you're inside of the real numbers. But if we're inside of our complex numbers, then we can have square roots of negatives. And so that's what we're going to be looking at. Now, we have two different types. We have pure imaginary numbers, and those are going to look like things that are just be I. So it's going to be like some number multiplied by our imaginary unit of I. So some examples of that. We could have something that's like 8I. We could have something that's like -2I. Both of those would be imaginary because they have the I unit, but they're going to be pure imaginary because it's just one number and I. We also have what's called complex numbers, and those are consisting of two parts. They have a real part and then an imaginary part. So our real part is going to be our A value. And our BI is going to be the imaginary part. So some examples of our complex numbers. Would be, so like 1 plus 2I, -3 minus 6I. So I have a real number, and then I either have an addition or subtraction sign, and then I have a number that's being multiplied by my I. Alright, so let's look at simplifying. So notice here that on both of these examples, we have negatives underneath our square roots. So that's going to tell us that these are going to be imaginary numbers. Anytime that we see that we have a negative underneath our square root, that should be our first indication that it's going to be an imaginary or complex number. So what we want to do in order to simplify that is we want to go ahead and break apart that negative. So we're going to say -1 times 27. Now, notice or remember that whenever I have two things that are being multiplied inside of a radical, I'm allowed to break apart that multiplication. That's only true with multiplication. It's not true with addition or subtraction. But here I have multiplication. Now, from our previous page, we know that the definition of our I unit is the square root of -1, which is what we have. So I'm going to replace my square root of -1 with I. And then we just need to simplify our square root of 27. Now, for those of us that don't remember, whenever we're trying to simplify a square root, we want to look for things that are perfect squares. So if I didn't quite remember what my factors of 27 are, we can go ahead and make a factor tree. So we want to think about what things go into 27. Well, 1 and 27 obviously go into each other, but the 1 isn't going to help me with my factors. So then my next number is 2. 2 does not go into 27. And then my next number is 3. So 3 times 9 gives me 27. And then 9 can be broken apart into 3 times 3. So notice that I have a group of 2, which is the 3 times 3. So I know that 9 is going to be a perfect square. So now I want to break apart my 27 into 3 times 9. And we want to do that just like because when we simplified before, because if it's multiplication, we can break that apart into be the square root of 3 times the square root of 9. And we know what the square root of 9 is. It's going to be 3. So we're going to go ahead and have I times the square root of 3 times 3. And then we're just going to have one last step just to kind of rewrite it. In general, if we have any numbers, we want those numbers to come first, then our I, and then the square root. So that would be our final answer. Now, on our next one, you want to do a similar process. So remember, our first step is to break apart the negative. And then we're going to get I times the square root of 2/16. And again, if we don't know what our factors of 216 are right off the top of our heads, we can go ahead and use a factor tree. So notice 1 obviously goes into 216, but again, that's not going to help us. So we could do 2. So 2 times 108 is going to be 216. Then 108, 2 will go in again, and we'll have 54. Then we'll have 2 and 27. Nine and 3, and 3 and 3. So again, remember that we're looking for groups of 2. So I have 2 2s and 2 3s. So if I think about it, that means that we could rewrite 216 as 2 squared times 3 squared, and then we just have a 2 and a 3 left over. Well, another way of writing 2 squared times 3 squared would just be to say, well, I want to write my squared on the outside, and then 2 times 3 is going to be 6. So we could rewrite that as 6 squared, and then again, our leftover is going to be 6 as well. And the reason we want to do that, remember, is because when we write now inside, we want to break it apart into perfect squares. Well, 6 squared is going to be 36 times, we have a leftover square root of 6, and we know that the square root of 36 is 6. So then our last step is just going to be to move that number to the front, and we get 6i square roots of 6. So those would be my final answers. Now, when we're simplifying, it's important to kind of remember some of these properties. And we're going to go over how we get these. And then I'm going to kind of give you a little rhyme that can help us remember. So notice that I to the first is I, which makes sense. Anything to the first power is just going to be itself. Well, then let's think about I squared. Well, remember, if we replace our I with the definition of what I is, we would get the square root of -1. Well, the square root of -1 squared is just going to give us whatever's underneath our radical, which is -1. So then, if I'm looking at I to the third, notice that we could break apart I to the third like they did there. It's I squared times I. Well, we already said that I squared is -1 times I, which is just going to give us -I. And then I to the fourth, we could rewrite as, like they did, I squared. Remember, when I have any exponent that's raised to another exponent, we multiply. So 2 times 2 would give me 4. So that's fine. And notice that if we replace our I squared with what we know it is, which is -1, and then we square that, we get a +1. Now, we should notice that in our next row, it basically repeats itself. So notice that I to the 5th is I to the 6th is -1, I to the 7th is -I, and I to the 8th is 1. So it's going to repeat itself in a cycle of 4. So the way that we can kind of figure something out if we have anything bigger than that is by looking at how many times 4 goes into that particular number. So if I had let's say to the 248. So we don't want to have to go through and figure out, all of these little things and try and multiply it out or whatever. What we want to do instead is think about, okay, 248. If I divide that by 4, we should get 62. Well, remember that we said that if we can rewrite it as a power raised to another power, we would multiply those. So I know that I to the 4th to the 62nd would get me 248. Well, we know what I to the 4th is. It's 1. And so if I have 1 to the 62nd, that's just going to be 1. Now let's look at something where 4 doesn't go into it. So let's say I had I to the 31st instead. Well, notice that 4 doesn't go into 31. However, if we think about division, well, 31 divided by 4, it can go into it 7 times exactly. And then we're going to have 3 left over. So what we're going to do is we're going to rewrite this. So it's going to go into 28 times exactly. And then we said we're going to have 3 left over. And like I said, the reason we want to do this is because now we can do with the 28 what we did with our 248. We can rewrite this as I to the 4th to the 7th. And then we have an I to the 3rd left over. Well, notice that just like before, this I to the 4th to the 7th is just going to give us 1. So then we're just going to have I to the 3rd left over, which again, using our little chart, gives us negative I. So in general, we can kind of just think about it as the remainder. So if I divide 31 by 4, I would get 7 remainder 3, which means that, notice, the exponent that I have on my leftover stuff is going to be 3, and then we just simplify. On 248, our remainder was 0, which means that it's going to go into it exactly, which means it'll get us whatever we get when we have just I to the 4th, which is 1. And like I said, there is a little like rhyme kind of that goes to it, or you can turn it into a song if you don't want to hear me sing. So I'm just going to tell you the rhyme. So it kind of goes, I to the 1st is I to the 2nd is -1, I to the 3rd is negative I, and I to the 4th is 1. So I to the 1st is I to the 2nd is -1, I to the 3rd is negative I, and I to the 4th is 1. So we can use those exponent properties to find any of our higher numbers, but we do need to know this first row of our chart. There's not really a way around it. Now you can't go through your steps kind of like we did before and think about, okay, I squared, if I square my square root, and go through those steps. So you can always find it if you need help remembering. However, it might be helpful to just kind of memorize it to some extent, those first 4. Alright, so let's look at some properties. So on our first one, we want to look at our number parts first. So we would say -5 times 3 gives us a -15. And then we have I times I, which gives us I squared. Well, our -15 isn't going to change, but we need to replace our I squared. Anytime that we have an exponent on our I, we need to simplify it. So from our chart, we know that I squared is going to be -1. So this is going to give us a positive 15. Now, be careful when we start getting negatives and we start doing operations with them underneath radicals, because our first step always has to be to pull out that -1. So we have -1 times 6 times -1 times 15. And the reason we need to do that is because we need to pull out our imaginary units before we try and simplify anything else. And we'll look at why that is in just a second. So I times I gives us I squared. 6 times 15 gives us 90. And hopefully we can kind of see, well, if I break apart 9, again, I'm trying to think of things that have perfect squares. So 9 times 10 is going to give me a perfect square of 9. So I could rewrite 90 as the square root of 9 times the square root of 10. So we get 3 square roots of 10. Now, we know that I squared from our chart is -1. So we're going to replace our I squared with a -1 and our square root of 90 with 3 square roots of 10. So our final answer is going to be -3 square roots of 10. Now, like I said, it's important that we do this first because if we notice, if I had multiplied my -6 and my -15 together first, we would have gotten a positive 90, which would have just given us a positive 3 square roots of 10. And so we would get that wrong. So what we need to do is make sure that we pull out our i's first. Alright. Now the reason that we go over these is because remember, we talked about how sometimes our quadratics don't have a solution, which is kind of true. So remember that our graph, if we had something that pointed up, we said that there was no real solution, which is true because we are putting real there. We do, however, have some imaginary solutions. So if we notice, we have x squared plus 64 equals 0. Remember that we just went over factoring, so we want to check and see if it factors first. Well, I have a binomial, but we do have a difference of squares formula, but notice that my operation is addition, so we can't use our difference of squares formula. So what we're going to do is I'm just going to subtract 64 to the other side. Then we're going to go ahead and take the square root of both sides. But remember, when we take the square root, we have to add a plus or a minus. So my square root and my squared are going to reduce, so we just get x. So then I get plus or minus the square root of -64. So again, we want to pull out our I first. So that's going to get rid of that negative in our radical. And then we just have the square root of 64. So then we get plus or minus I times 8. And again, just rewriting it, we get plus or minus 8i. So our answer is going to be a pure imaginary number of plus or minus 8i.